entities. So for each entity, we create what? A relation. So we can have the one relation for each entity. Okay, at that time, don't forget, we need to select one of keys as a what? Primary key. What? According to the relational model rule, each relation should have one primary key. Exactly one primary key. No less than one, no more than one. One primary key. Also, the other the attribute can be converted into attribute, including composite attribute. Composite attribute, you can take care sub-component. Okay? Except what? Multi-valued one. Multi-valued one, you cannot take care of multi-valued one. According to the rules in relational model, each relation should have the atomic single value for each attribute. However, multi-value, a name implies it's multi, so we cannot take care. We will take care later. That is entity. For example, here, employee, department, project, we can create a relation. For example, SSM will be primary key of employee relation. Name and number, among that, between them, we will select primary key. For we selected this, you can consider the performance or the pattern of your application or user requirement. So that similarly, we can select the number. For this, the location is not a multi-valued, so we can create a tree. However, locations in department we will take care of later. The next step is the weak entity. Weak entity is the same as the entity, except that it doesn't have the full primary key, only partial key. So we need to make, okay, according to the rules in relational database, it must have one primary key. To make it a primary key, we can model. We need to identify the primary relation entity that is the weak entity. For example, here, the dependent. Using identifying relationship, we can get the key of employees. So SSM plus name can be primary key or the weak entity. The other are the same as the first step. The next step is, next three steps is for the relationship based on the cardinality ratio 1 to 1, 1 to many, many to many. In step 3, 1 to 1, there are three ways, three methods to map from 1 to 1 relationship to relational model. Among them, we usually use the first one. First one is creating, move the relationship to either of the entities. Then add will be an attribute of that the corresponding relation. Then create the foreign key to the other. For example, here, this is a one-to-one relationship. We move all the attribute of this to either of them. How can we decide? It depends also. You need to consider the user requirement or future performance. By considering all of this, we decide to move here. Why? Because all department has the manager. But some of employees do not have manager. So the other will be waste of space. So we will move the manage to this one. That means start there. Also, we should create manager social security number. That means that we move the manager into this one. Then this manager is also employee. Should be part of the employee. So we can create the foreign key like this. So from manager social security number. Manager start date. Manager social security number depend on the SSN. That is the third step. And in second method of the third step is, why don't we merge? Because it's a one-to-one mapping, so we can merge it into one. So employee under what department manager relation. Okay. However, in this case, if we merge it, there are a lot of the missing null column, null attribute. So it's not a good way. Also, sometimes many of transactions access only employee. Sometimes only department, not together. So in that case, it's not a good choice. The last one is, why don't we create the manage relation? It will be manage table when you create the real database. Okay? Then at that time, we can create the 2 foreign key. When is a good choice? First for the creating new relation. For example, you have a lot of or very important transaction to access manage information only. Okay? This is for the executive. Yes. The server or system. So system for your executive was your CEO. So he or she does not want to delay so very fast response time. At that time you can create the separate table. Separate relation. That is the second step. Next, first step is one-to-many. Most popular one is not difficult. We can just create what? Foreign key. But when you create a foreign key, it starts from here, many side to one side. So in many side, you can add attribute that represent the department, the one side. For example, DNO. Create the DNO attribute that refer what? Primary key of this one. In case you select the name as the primary key, you need to create D name. Okay? Because as we discussed a lot, according to the relational model, foreign key, the referenced column, referenced attribute in foreign key should be primary key of that corresponding relation. Okay? So which means DNO. No, DNO is not the primary key over here. So we can use D name to for the referencing foreign key attribute. That is the many to one, one to many. Another example here. So add DNO, then foreign key. Another, we already took care of this. So the next one, one more thing is one to many. So manage a social security number. Refer the social security number like this. Okay? Then the fifth step is for many to many. Many to many is a little bit tricky because we cannot identify the data because many. So to address that problem, we can create the associate relation in between. So for example here, the work zone. How many hours each employee works on specific project? We should know employee number and project number, then number of hours. That is the key. Employee social security number and the project number, P number, will be primary key. Then attribute this number of hours. So you can create the 2 foreign keys from that associating table. The next one, step 6, is for multi-valued. Multi-valued, the reason why we consider separately the multi-valued is relational database model does not allow the multi-valued one, only single-valued one. To address that problem, the only solution, actually that's not a good solution in terms of performance. Why?
Because you have to create a new relation set. A new relation set that relates to these to that location in the department.
So we define locations as location is what? Attribute of department. It's just part of department. It's not very important. It's not independent object things, which means it was not entity. However, because of the limitation of a relational model, we need to separate it. But that's not a good choice. When you access the location data, probably you need to access the department information. What is the location of your department? So we should know what? Department information. Then location information. We need to access both of them. when you access location information and department information, which one is better? Access two different relations or one relation for department that include department location. Which one will be faster? Definitely one, right? So to address this one, we need to do later join operation. Have you ever heard about the join operation? Join.
Yes.
That is a one key feature, characteristic of relational database model. You need to join two tables, three tables, many tables. Okay, so you can access many data easily. However, so when you inform, so you need to inform your student. So me, so I need to inform my student. Tomorrow will be cancelled. So if you are all together here, I can announce just one time. However, if everybody scattered around the university or around the town, I should visit each and every one course. It takes a longer time. It's the exactly same problem. When you access the data is located in one place, so faster than this. Join operation, even though that is the key features of relational model, that doesn't mean that's faster. Join operation is one of the worst operation in terms of performance. It takes a long time. It's a very, very expensive. Okay, so if you can access the data without join, that's much, much better than very complicated SQL. Okay? So simply it's the best. It's the same thing. However, so that is the reason this option, step 6, actually is not good choice, but no way to represent multi-valued one. So that is the reason we separate as a relation. The last step is for ternary relationship. We do not have the ternary relationship in company database. Instead, we took a look at the example of this. The supplier supply the part to project. So if you consider binary, that's different from ternary relationship. Instead, we are going to create a supply relation and create n number of foreign keys. Then primary key of supply will be the combination of all three primary keys. Okay? In this relational schema diagram, foreign keys are removed, so you need to add. That's the whole thing that we discussed the last class. However, as we have learned in ER modeling, ER model is very useful, powerful, however, still limited to represent very complicated relationships. For example, employee, we have the employee, the entity. Then sometimes employee can be classified into secretary and technician and engineer by job type. Okay? But all of them are in the same entities. It's one entity, but it's classified, specialized, sometimes generalized. Can we represent such a complicated relationship with ER model? No. So that is the reason we consider ER model, extend ER modeling or enhance the ER modeling by adding one concept of super and subclasses that are specialization and generalization. So we need to take care of it in relational model. So not turn off this. That's small. I think that's much enough. So, for example, here. So we have employee. So we have what? The secretary, engineer, technician, and technician. So actually all of these are in one entity, one semantic, one meaning. That is employee, but it's specialized. Or from the secretary, engineer, technician job type is generalized to employee. If we just consider the step 1 through step 7, is it one entity? Actually not. These are the one entity. So we cannot take care of it. So we need to think about different steps, different approaches to create one. What is our goal in this class right now? We need to build a relational schema diagram, relational database model based on what? ER modeling. So we need to take care of this. So we are going to consider different options. For example, why don't we, even though this is a subclasses, why don't we consider each of them as an entity that create a relation? Okay? That can be the one option. So, for example, so in this example, we have just the same thing as this one, employee, superclass, and 3 subclasses here. So first option, option 1, why don't we consider, regard each class as an entity, which means we can create employee, entity, then and relation, secretary, relation, and technician, relation, and engineer, relation. Okay, then apply step 1 through step 7. According to the step 1, employee should have the primary key. What can be the primary key?
SSN.
SSN, definitely. So underline. Then name is a composite, so we can create the F name attribute. Middle name, initial attribute, last name attribute. We don't need the name. Okay? Instead, 1, 2, 3 subcontent. First date, address, and job type. For secretary, in ER modeling, does it have the key attribute?
No. It will take
No?
it from the SSN.
Actually, yes, but it's from superclass. In other words, superclass inherits all the characteristics of it to subclasses. Actually, it has the key. What is the key? SSN. So we can use SSN. Why? Because each relation must have one primary key. So that is the primary key. The other attribute, actually we don't need the other attribute. It can be found. So, however, typing speed is not in superclass, so we need typing speed. Similarly, technician. Technician, what is the key of SSN? So it's the SSN underline, attribute T grade. And engineer, SSN. And engineer time. Okay, that's it. Is that all? No. What else? Relationship. We do not have a relationship.
Composite.
Composite. We already took care of composite. Foreign key. From primary key of these subclasses. This social security number, how can we find name of secretary? We should take a look at superclass. How can you find the specific employee? Using SSN. So that can be represented by foreign key from subclass to superclass. Okay, otherwise we can have the secretary, not in employee. Does it make sense? No. It's the problem. So to keep such a constraint, we need to create the foreign key from subclasses to superclass relation. Okay, that is the first option.
Professor,
Yes.
this operation is creating foreign key because I was aiming at that operation when I said like creating relationships.
Oh yes. So I'd like to make clear as possible to use terminology. Relationship. Actually, the name of the object in ER model. So don't be confused. But I understand, I know that relationship is the general relationship, like the foreign key relationship. Okay, but if I'm saying the relationship, somebody may be confused. Is that the relationship in ER modeling or the friendship, whatever? So that is the reason. Okay. Then this is the first option. Is that all? The option? No. For example, let's say this is the generalization process, which means first we identify secretary, technician, engineer, then come up with employee. So I realize from the customer request or data or analysis of your application, all the application can be classified by either secretary or technician or engineer. Okay? Actually, we don't need any transaction regarding to employee. You understand what I'm saying? Even though during the EI conceptual modeling, I come up with one generalized employee, but your transaction actually need only secretary, only technician, only engineer. Which means whenever I access all the information about secretary using this option, I need to access this data, then going to employee. So we need to join operations. We need to visit 2 rooms, 2 houses. Why don't we merge such information? Which means we do not consider employee, only consider what? Subclasses. Okay? How can you do that? We can inherit all the characteristics, all the information about employee to each subclasses. Then, second option is, one is for secretary, another one is for technician, another one is for engineer. What is the key of secretary? Definitely social security number. Then it has the typing speed and all information about employee. Like do we need another social security number? No, we don't need. We already used the social security number, first name, middle name initial, last name, birthday, address. Actually, we need a job type, but it's already classified. It's up to you. So I'd like to keep because it's mentioned over there. Then, social security number, technician T grade. Then, exactly same thing. First name, middle name initial, last name, birthday, address, and job type. What about engineer? SSM, engineer, time. And first name, middle name initial, last name, birthday, address, job type. Is that all?
Foreign key.
We have to
No,
create it.
we don't have.
Foreign key?
No, we don't have.
Do we need a foreign key first?
No, we don't.
No.
Yeah.
We don't need foreign key. All of? In between? Sometimes yes, that depends on. No, in this case, we don't need foreign key. How can we get the foreign key? For example, social security number to this social security number, they are separated. Okay? They are different. In case Lee is in secretary, Lee is technician, you need to create 1 tuple for secretary, 1 tuple for technician. It may be possible you lose consistency. Consistency means I'm in here. I'm in technician. Then sometimes later I move to another place. I got the new address. However, I only informed the secretary department. Secretary, which means it's updated, but not updated here. It's possible because we do not have foreign key constraint over here. We cannot have foreign key constraint. They are separate. You should be careful when you choose this option. Okay, but it's good for what? Only access if the subclasses are independent. Okay, in terms of transaction. Then, any other option to take care of this one? So we, in here, option 1, we consider separately for each super and subclasses. In this option, we focus on subclasses only. What about superclass? So even though we generalize, so think about, this is a specialization, which means first we identify employee. We have employee, but sometimes we can classify the employee by secretary, technician, engineer with job type. That means most of the case we access only employee information. Those are enough. However, rarely, sometimes, very rarely, we can access secretary information or technician information or engineer information. So why don't we come up with just one big entity? Because anyway, this is one entity, one group of data. That means one relation. So option 3, we have employee relation, one big relation for employee. Okay, then what is the key? So we can start from first name, middle name initial, last name, birthday, address, and job type. Depending on the job type, we need information about what? Key typing speed. Depending on job type, we need key grade information. Depending on the job type, sometimes we need engineering type. Okay? For example, 111 Lee, whatever job type is a secretary, and typing speed 100 word per minute. What about T grade? That's not possible. Okay? In other words, it should be null data. Engineer type, null data. Because we can have only one type of job here. What about next? There is the James and whatever. This is engineer job type. What about typing speed? Should be null. Because James belongs to engineer. The other information actually we don't need. However, since we compile into one entity, no way to avoid such a useless information. So we can use not engineering type. Engineer type is mechanical engineering, whatever. Okay? In case technician, only technician will be T grade. Okay? That is third option. When is this a good choice? In case this is disjoint. Okay? When is disjoint, one of them. Also, we can, when the most of transaction access the employee. So we can come up with one. Okay, this is the third option. Then you may be curious. What about
Overlaps.
overlap? Overlap cannot use this option. So in fourth option, last option, we will create one with employee. This is employee. This is employee. Okay, start from employee. SSN, first name, middle name initial, last name, birthday, and address instead of job type. So for example, Lee is in secretary and technician. Can I use the job type to represent secretary plus technician? No. There are two values. So disobey the relational model. Instead, we are going to create the column for what? Have you ever heard about the Boolean data type?
Yeah.
Boolean. How many different values do you have in Boolean? It's a 0 or 1, yes or no, true or false, positive or negative. It's two, binary selection. Okay? Actually, in database, we have one more. Okay.
No.
Null. So true, false, and null. Okay? You need to keep your mind. That's the one thing different from the other data type. Okay? That's the different story. Anyway, we can use such a Boolean data type. Whether is it secretary? Yes or no. Is it technician? Yes or no. Is it engineer? Yes or no. If you belong to all of them are yes. That means secretary, yes or no. SECYN. So here it will be 0 or 1. Yes or no. Or true or false. So then, if yes, we can have typing speed. Similarly, is it technician? TECYN. Ask if yes, we can have the data like the T grade. What if not technician? It will be null data. Okay? It can be none. So engineer, ENGYN, and engineer type. For example, Lee is in secretary and technician, which means 111 Lee secretary, yes or no? Yes. You see, he is in the secretary, so Y. Typing speed 100. You see, in technician, yes. So technician, yes or no? Y. Technician, grade, senior. And engineer, you see, engineer, no. And then engineer type, none. This is the last option for overlap the data. So you need to select one of them to convert generalization special or specialization super and subclasses to relational model. Why is it so complicated? Because relational database model actually cannot take care of such a semantic meaning of this one. Instead, we need to use different option for each meaning. Okay? For example, if your application access subclasses only, at that time you better select this option. However, your application program access only employs superclass, but they are disjoint. In that case, this one is a good option. But it's general, so we need to take care. There are operations for subclasses or sometimes superclass. First option will be good choices. So that is super step 8. Okay, there are 4 options. One is yes.
What is the benefit of going with generalization?
Benefit?
Yeah.
So benefit means instead of the discussing about the benefit, why don't you think about your data? So when you model the conceptually, so I have only employee information, then You don't have to create the generalization or specialization or superclass, subclass. But you have the employee data. But when you go over the employee data, you may realize the employee can be classified into part-time employee and full-time employee. At that time, you need to represent such a characteristic on your modeling. Okay? ER modeling, no, we cannot do that. We need to create one entity, one entity, one entity. So that was the reason we expand into generalization, specialization. That is a conceptual model. So using ER diagram, you can understand. Yes, this is one entity employee, but it may be classified into two groups, part-time, full-time. Then, here relational database model actually cannot represent, cannot show such a complicated relationship, super and subclasses. So we consider such a different options depending on your requirement. Yes?
So actually in real time, the data is very complicated.
Uh-huh.
So how do we distinguish that, okay, I have to go with this submodel or I have to go with this one? How do I select my...
There is no general rule. So it's based on the only thing I can say is very the dominant cases, like when your application access only this, that's not true sometimes. You need to decide based on your requirement. It can be based on your experience, it can be based on your customer suggest or your seniors suggest. So you need to decide which one is good, which one is not. Sometimes you need to go back after you select the second option. I thought only subclasses enough to manage. We don't need the employee table, but your developer, your customer may complain. Why we do not have the one big table? So whenever I access the average salary of employee, I need to access 3 different tables, right? So it's time consuming, and sometimes we have duplicated the seller, the employee. At that time you need to go back. Okay? Then change the model. So while you are model, conceptually, you need to decide the correctly, appropriately. It's not easy at first time. There is no general rule. It's very hard to say, yes.
With the third option, I can see that there is maybe lots of wasted space with...
That's the drawback. That's the disadvantages. So you need to juggle it. So there's no perfect solution. As I said, relational model is not enough to take care of all the requirements. It's not a very sophisticated model. So you need to juggle it. We have the bunch of space. Space is not the problem. Okay? Time. You can select your option. So in your project, you need to have at least one super subclasses relationship in your database. Sometimes you may not. You can intentionally create. So many of you guys have the customer, right? Then customer can be classified into 2 customers, registered customer or non-registered guest customer, or the male customer, female customer. You can intentionally make the case. Then when you map into the relational model, you can decide. We have a male, female. Actually, male, female can be the attribute, which means we can select third or fourth option. It's a disjoint. We can select the third option. Okay? So, is it the man or woman? Male customer, female customer, male customer needs something man stuff and something like that. So you can intentionally create such a case. Then probably I will ask you why you need to select this option to create a relational model for super and subclasses. At that time you should be ready to answer. Okay? Yes?
Can you have multiple options and take it?
Then you need to create the multiple table. That doesn't make sense. Okay? You need to select one of them only. Then, let's see other example. This is the first option, but in this diagram, need foreign keys. Okay? So first option, but it needs a foreign key. think we have more samples. Let's see. Yes, this is the third option, right? It has a job time and typing speed, T grade. Then this is the yes or no? No.
This is the
What about this? Why don't you take a look at another example? This is a part, and part has manufactured part, purchased part. Actually, in our previous example, it's overlap, but it can be anything because it's blank. So, in this example, we are going to use all of this. We are going to use all of this option. First option. For each, which means we need part. And we need the manufactured part. We need purchased part. Okay? Then part number is the key. Then description. Okay? Then if you want the part type like this, you can add, but only in case disjoint. Okay? But here, actually we don't need, because it's already specified. For manufactured part, what is the key of manufactured part?
part number.
Part number. Okay? Part number, then list of drawing number, manufacturer date. And this definitely part number. And supply name. Then list part. Don't forget foreign key. Okay? Second option is we only consider manufactured part and purchased part. Manufactured part has part number and description from superclass and drawing number and manufactured date. Purchased part, part number, description from superclass and supplier name and list price. This is the second option. We don't need a foreign key over here. Okay? That doesn't mean we don't need such. It is not possible to create a foreign key relationship. They are independent of each other actually. The third option, one big merged one, relation part number, then description. If this is the disjoint, we can have a part type. Then this drawing number and manufacturer date. Then that supplier name. Then list price. That's it. Then last option. Part number is the primary key and description. We need to ask whether this is the manufactured part or just part. Is it manufactured? Yes or no? Then two. Actually, I forgot this one. You can put the batch number, drawing number, batch number, and manufacturer date. That's it. Then for purchase part, is it purchase P-U-R-C-H, yes or no? You can name it whatever you want, but as long as the name, attribute name, represent the meaning of this. Okay? Do not make the attribute name as the A1. Okay? I do not know what that is. Then you may not get the full credit. And supplier name. And list price. There are 4 options. You need to select one of them. Just for training purpose, I showed all of these options, but you don't need it. Sometimes, if this is the disjoint, you don't need this option. Select it. Okay. Then, this one is use the flag. Okay. So this is actually the last option. In case the manufacturer flag. Flag means it's a 0 or 1, yes or no, flag. So you can have this data, the other will be the, if no, this is the null data. Similarly, P flag, which means project the yes or no. If yes, you may have the data. Sometimes you may not have the data because it's not null. This can be null, but mostly it has the data in case this is a yes. Supplier name yes, and the data is the price data. Yes.
What's the difference between option 3 and 4?
Option 3, for example. Here, this part it belongs to, it can be manufactured and purchased. Okay? Can you insert the data over here?
No.
No, that's the difference.
Oh.
So you add part type,
Yes, part type.
only this.
Part type, any attribute in relational model can have only one value. That is the limitation. If there is possibility to for multi-valued one, you can have something vector or object, but this is a relational model. That's not possible. That's the limitation, drawback of using relational model. Okay? There is a object relational model database. It's called ORDBMS. Actually, ORDBMS is not the traditional database model. Instead, somebody complained a lot to the Oracle Informatics DB2. We need something multi-valued one, like the object-oriented concept. So they add little bit concept of object-oriented concept, like the user-defined data type, UDT. Okay. So in Oracle, yes, you can create the data type. Also, you can create the multi-valued one, not frequently used. But there is a function that makes it very complicated. It's disobey the rule of relational model. Okay? Then we have a little bit complicated example. Yes?
Which one can be used in the overlap?
Overlap is the last one. Overlap means I can be the A part can be purchased as well as the manufactured. I can purchase the part that is manufactured, then purchase and manufactured. That is overlap. Belongs to 2 subclasses. At the time, third option may not be available. So you can select the last option, or first option, or second option. But in case the second option is there, will be dangerous to break your consistency. Okay?
So only the third options cannot be used in the overlap.
Overlap, yes.
Others can.
Yes. Then, this is a little bit complicated example. How many entities do we have here? One? Many? It's just one.
Only one.
There's only one, but 1 degree of super and subclasses. Also, subclass is a superclass of this. Also, it's a superclass of this. 3 degree. How many? 1 super subclass. 2, 3, 4. Also, 5. this is multiple inheritance. We have biological parent and adaptive. Okay, two different types of parents. So this one may inherit all the characteristics of employee, definitely person, yes, and as well as the student. So we will see how we can take care of this. Also, in case you have subclasses of subclasses, okay, in that case, you can, for each super and subclass, you can select one of the options, which means this one can be first option, then this one can be second option. It doesn't have to be the same option for all super and subclasses. And also this one can be first option. This one it will be second option, something like that. So, which means, let's take a look at this example. There is a mistake. We should have the foreign key to SSN to SSN. Then, in this relational model, relational diagram, what options is selected for this person, employee, alumnus, student? For this, each option is selected for person, employee, alumnus, and student. First option. Second option. Third option. No answer. Fourth option.
This is the first option.
First option. Raise your hand and try to see how many. Roughly 1/3. Second option. Third option. No. The last option. 1, 2. Why do you select the last option? First option is one big relation, right? Then with the yes or no for subclasses, right? Yeah. Then how many? How many relations do you have? For person, employee, alumnus, and student. Yes. 4. That means it's the first option. Okay? From first option, what is the first option? Create relation for person. Create relation for employee. Create relation for alumnus. Create relation for student. Then we create a person relation. We create an employee relation. We create alumnus. Yes. And we create students. This is the first option. Okay, then I know you are confused with this one, right? We will see why this one has that kinds of thing. Yes. What about the employee? Yes. Employee, staff, faculty, and student under assistant. Which option is selected for employee? First option? Second option? Third option? No, nothing. Fourth option?
Third.